Hey there, and welcome. Have you ever really stopped to think about how your car just works? I mean, everything from the engine to the airbags to that touchscreen you use for music, it all just communicates seamlessly. Well, today we are pulling back the curtain on the incredible invisible network that makes it all possible. We're going to dive into the hidden nervous system that makes your car tick. You know, when you think about a modern car, it's really less of a machine and more of a supercomputer on wheels. Seriously, we are talking about hundreds of processors and these little things called electronic control units, or ECUs, all working in perfect sync. But for that to happen, they need to be talking to each other constantly and instantly. And that really is the million-dollar question, isn't it? How do all these separate little computers talk to each other so reliably? I promise you, it's not magic. It's actually a marvel of engineering that started with a very, very tangled problem. Yeah, see, back in the 80s and 90s, if an engineer wanted to add a new feature, say a power window, they had to run a dedicated wire all the way from the switch to the motor. So you could imagine, right? More features meant more wires. It quickly turned into an absolute nightmare, a heavy, expensive, tangled mess that was just awful to build and even worse to repair. So the engineers came up with this brilliant solution. They took their inspiration from the most complex communication system on the planet, the human body. They decided, you know what? Let's give the car its own digital nervous system. And that solution is called a bus system. It's a fantastic idea. Instead of thousands of individual point-to-point wires, you have this shared data highway that all the different components can just plug into. The whole key here is sharing information in a really efficient way. And this image, well, it just illustrates the concept perfectly. The ECUs act like these little mini brains that control different parts of the car. And the bus system, that's the network of nerves, carrying signals between all of them. So when your foot presses the brake pedal, a signal zips along the bus to the braking ECU, which then tells the brakes to engage. See? It's all connected. But think about it. Not all nerves in your body are the same, right? You've got nerves for those super fast reflexes and others for more complex thought. While a car's network is exactly the same. It uses different communication languages, or protocols, for different jobs. The main players you're going to hear about are LIN, CAN, FlexRay, and the really big one for the future, automotive Ethernet. Each one is a specialist, totally optimized for a specific set of tasks inside the vehicle. Okay, now what's so cool about this is how well the analogy holds up. Let's break it down. LIN is for simple, slow stuff, like adjusting your seat. Think of it like a basic reflex. CAN is the real workhorse, kind of like the spinal cord, handling all the critical engine and brake data. Then you have FlexRay, which is for things that absolutely positively cannot be late, like steer-by-wire. It needs perfect timing, like a gymnast's coordinated movement. And automotive Ethernet? Oh, that's the optic nerve, pumping massive amounts of data from cameras and high-res displays. But as these networks got more and more crowded with data, the way they communicated had to evolve. They had to go from a system where basically everyone was shouting at once to a much, much smarter conversation. So originally, communication was signal-oriented. Now, I want you to imagine a super crowded room where every single sensor is constantly shouting its status. My temperature is 20 degrees. My speed is 50. My pressure is 30. Just over and over again. Everyone in the room hears this, whether they care about it or not. The new way is service-oriented, which is way more like a polite, direct conversation. A component can now just ask, hey, tire pressure sensor, what's your current reading? And only then does the sensor actually respond. Much better, right? The big problem with all that shouting is that it creates a ton of noise. It just clogs up the network with useless data, and it forces every single ECU to listen to and filter out information it doesn't even need. As cars got smarter and packed with more sensors, this digital traffic jam became a really serious bottleneck. The power of just asking is its efficiency and its intelligence. It dramatically cuts down on unnecessary traffic, which frees up all this precious bandwidth. This makes the whole system more flexible, way easier to update, and ready for future upgrades, which is a huge deal in modern car design. And this isn't science fiction. This very transition is happening right now in the cars rolling off assembly lines today. So where is all of this amazing technology taking us? With this powerful digital nervous system in place, what does the future of driving actually look like? The future is all about speed, but it's also about real-time data. And automotive Ethernet is the absolute game changer here. It's not just about raw speed. It's about providing that massive, low-latency bandwidth needed for the data fire hose that comes from advanced cameras, radar, and LiDAR, the actual senses of a self-driving car. For those systems, a delay of even a few milliseconds is totally unacceptable, and Ethernet delivers that crucial reliability. So, why does any of this matter to you? Well, because this powerful, high-speed network is the bedrock for everything that's coming next. It's the thing that makes safe, responsible, autonomous driving possible. It's what powers those rich, fluid infotainment systems we all want. It lets car makers send critical software updates over the air, just like your phone. This stuff is fundamentally reshaping how our cars are designed, built, and even maintained. Which leaves us with a pretty fascinating final thought. We are literally building cars that need to see, think, and react faster than any human ever could. So the question isn't just about making their nervous systems fast. It's about making them flawlessly reliable every single time with zero room for error. And that is the incredible challenge engineers are tackling right now. Thanks for joining me on this deep dive.